Excuse me, can you hear me?
Yes.
Yes, we can hear you.
Can you see the presentation?
Yes.
Oh, thanks. And now let us start.
Sorry, before you begin, Kathy Wang, do you mind leaving the meeting? I accidentally had admitted you.
Sure.
Thank you. Sorry about that.
But it said to enter the meeting 10 minutes earlier. Should I just wait in the waiting room?
Leave and then rejoin, and I'll wait until the right time to admit you.
Gotcha.
Sorry.
Okay, thank you.
Thank you.
Okay, I think we're ready to begin, Victoria.
Yes, I think we can start. Hello, my name is Veronica Victoria, and we are the team of Petersburg, St. Petersburg Polytechnical University, and we are named as EnergyLoop. And we started to analyze the background of California. Yeah.
We analyzed the energy sector of Californian energy system. Our findings are listed in the left part of the slide. One of the main points we found out was that the region is oversupplied in the energy sector, since it only consumes about 26,000 megawatts, while having the opportunity to produce about 31,000. And at this moment, there is an interesting project going on in Californian state. It's called the Western Climate Initiative, and it covers about 600 enterprises who willingly pay for their CO2 or emissions of equal kind. The amount of emissions is about 342 million tons every year, and all these companies combined pay for it about $3 billion yearly. The main problems we found out while researching the energy sector of California are listed on this slide. One of them being that most of the renewable energy source, most of the renewable energy-based power plants that are situated in California are based off of solar energy. The exact percentage is 56%, which has its serious consequences on the energy sector of the region. And after a Q&A session with an expert, we identified another problem, that is inefficiency in produced electrical power that leads to it being not competitive in the energy market. Because of that, there are serious consequences that to solve the problem, we found three solutions. One, three points of solutions which we combined into one big project that we would like to present. It being the hydrogen production plant, which uses electrolysis to capitalize on excess energy produced by solar power plants during the hours of lesser consumption. Mainly, we found out that those hours are from 8 a.m. till 4 p.m. The benefits are addition of a power consumer of this type to the energy system solves the dark curve problem. Okay. The properties. the conclusion. All economic indicators and project characteristics are based off of mathematical models, and so we use the discounting methods to evaluate it while using analogy methods, and also we wrote a real neural network to get to fit energy systems special features of California and to predict its consumption. The effects are listed on this, the main effects of our projects are listed on this slide. Thank you for your attention.
Great. Great, thank you. And understood, we got rushed a little bit just because we're going pretty quickly. But yeah, thank you. I have your presentation in front of me. One question is why did hydrogen or electrolysis for hydrogen end up being the technology you recommended? And I'm curious if you evaluated any other technologies and why you thought electrolysis was the best, particularly from a cost standpoint.
The answer to that question is that most of our team members have a considerably serious background in the energy research, so we worked on several projects considering the cost effectiveness of different types of
technologies, and also
hydrogen production. And yes, electrolysis is not the most electrolysis is not the most cost effective. When it comes to all the methods, the most effective one, I think, is methane conversion. But on the other hand, methane conversion is much less economically friendly. Moreover, it uses a lot of natural gas, which is dominant in the California's energy sector. So we didn't want to increase the influence of energy gas consumption even more. We wanted to focus on some green technologies, and if we look at the green technologies that are able to produce hydrogen, electrolysis is, I think, the best one, since all the other ones are either theoretical and cannot be properly used nowadays due to the level of technological advancement, or they are not as cost effective, mostly not as ecological, and are not as developed.
And moreover, you know that in California there's a lot of oil refining, and for that, for this type of production, you need a lot of hydrogen. So you need to produce it somehow. Nowadays, it is produced on the plants itself, but it's not the cost effective for the oil refining companies as well. So we produce cheap and clean hydrogen for these companies, so it will be, there will be benefits for all consumers of the market.
Yeah. And maybe one last question, if you can tell me a little bit more about your neural network model and the value that that brings. It looks like you're using that to do load forecasting. Maybe tell me a little bit more about that model and kind of what the inputs and outputs are.
Well, yes, of course. It means that we trying to predict the demand of the electricity consumption in the region. For now, it's they're using a lot of models for now, but they are not quite accurate for this type of prognosis, and we just trying to improve the accuracy. And as you can see, we achieved a very high level of accuracy of about 99%. We managed to do this due to various inputs. For example, we managed to find out data about the temperature and other climate statistics. So as well as the production of the electricity from different types of fuels, carbon emissions, and other data. For example, is it the weekend or not? Because it depends on which day of the week the consumption is changing by. So, and we used LSTM architecture for neural network due to it's the most suitable for forecasts and timeline trends. So
yeah, and the main output of this neural network model is being able to forecast the consumption more accurately, which in
Thank you,
our
Energy
opinion
Loop
could lead
team.
to.
Time is up. We'll move on to the next team. Thank you.
Okay.
Great. Thank you very much.
Thank you.
Energy Loop.
Bye.